Hi, this is Somni Bhartia and welcome to TFiR Insight. And today we have with us James Lamberti, Chief Marketing Officer at Applitools. James, first of all, welcome to the show. Can you tell us, what the company does? What problem are you trying to solve for your users?
Yeah. So Applitools actually we invented Visual AI, which is a computer vision AI technology that is able to inspect any screen, any viewport, any image on an application, the same way the human eye and brain would, right? And in doing so, we're able to apply that technology to help engineering teams build and release their applications in a CI/CD, a continuous integration, continuous deployment fashion, while ensuring that the quality, the visual and functional quality of the application, so think about all the front end aspects of the application, are look and operate and function exactly as intended by the engineering team. And obviously, the importance of this can't be stated enough, especially with the situation we're in now, right? I mean, with consumers and customers forced to live with your brand interactions digitally, right? Digital transformation is kind of the buzzword we all use, but really it's about making sure these engineers, as they're developing and releasing their applications, they do so using our technology to make sure that quality and release velocity are as strong and fast as can be.
And since you did mention the crisis that we are all going through, um, have you seen any change in the way your customers are either consuming your technology or looking at their infrastructure? As you rightly said, you cannot even send a lot of engineers. So can you talk about that? How it impacted your customer base?
Interesting part about the software we built around it. Obviously, Visual AI itself is the core technology. It's vitally important. We built a platform around that technology. And one of the things we've learned through this crisis is that that quality engineering and teams that are forced to now work 100% distributed suddenly are seeing value in the collaborative aspects of our technology that we knew were there, but have now suddenly become that much more important when you have a distributed team still trying to submit code and release incredibly quickly. And what I mean by that, if you think about a visual of the application, anybody can use our technology in a collaborative way. And the way we're set up as a piece of software is the Visual AI actually literally takes screenshots of the application and will actually highlight when we see regression, when we see a bug. And so the benefits for these teams working in a distributed environment, for the ability to collaborate and literally see on screen the visuals, as opposed to having to dig into code that is, it's really hard to know when you look at a piece of code what element or what aspect of the UI is impacted by this code. It's much better if you just look at the page and the software tells you this is a regression. And then, by the way, we have features that allow you to say, for that regression being observed, what underlying code's causing the problem, and by the way, what Git repo is it associated with. So that aspect has always been there. It's a tremendous part of the ability for the software to help teams collaborate. But in this environment, we've had people write us and be like, "Look, I don't know what we would do to release a quality were it not for the Applitools software, because of the collaboration and the ability to visualize things and continue to move quickly, even though we're distributed."
Once this crisis is over, the way companies are changing the way they work, what would the because there, I mean, I don't want to dilute the great, I mean, it's a serious topic, so I don't want to dilute that. But there are a lot of good things that would come out of it, because we never looked that suddenly we'll be locked in our houses, people cannot even travel, so the way it has changed things now, how much of that will move forward and become a norm for, as you said, distributed collaboration, and so these are the things. Yeah.
I totally see what you're saying, and I see the same impact. Oftentimes it takes a crisis like this for us to transform how we operate and how we work. I think this is for sure that type of transformation. And a lot of high tech companies, a lot of startups, they understand already how to work in a distributed manner, how to work remotely. But I think for some of these larger companies that frankly, it's hard for them to change as quickly as a smaller company or a more technically oriented individual team. I think the lasting impact of this is going to be that a lot of these large companies that maybe were resistant to distributed work environments or were holding on to methods of work that required that physical, interaction. I think they're now going to realize like this is actually possible. And in some ways, at least in our case, the benefits of our technology and the collaboration that features that are essentially built in, I think they actually, again, going back to my previous point, those have become amplified. And I think going forward, we're going to see quality engineering, whether it's done by the developers or by by more of a typical QA team. They're finding it's going to be much easier to work and manage quality in a distributed environment, and going forward. And I think we're going to see our position in market, frankly, probably improve or accelerate because we are innovating, right? This is an innovative way for these teams to work. And so that innovation, I think, accelerates when you have a change like this. And it's a great example of where AI, I think the adoption of it, the use of it, accelerates out of a crisis like this. Again, not to belittle at all the consequences economically and for individuals. We are not seeking advantage here, but we are seeking to sustain an economy and to help people work smarter and better, just like we all should be.
Applitools also came up with a report recently. So tell us a bit more about the report.
Yeah, the report. So, look, you know better than anybody. You talk about this all the time. I'm sure AI promises a lot, right? There's innumerable numbers of ways in which we can see AI already impacting us, and we see it continuing to impact us even more so in the future. But from my point of view and from our point of view, there is a lot of noise, right? There's a lot of people claiming AI that's not really AI. In our case, it's true computer vision. I mean, for the scientists out there, it's Google TensorFlow models with stacked neural networks. I mean, we're literally taking billions of images and training our technology to look at it the way a human being would. But for us to cut through and really not just be a buzzword for a developer or an engineering team, but really to say like, look, this is real. This is impactful for you. That led us to, the design of this report. And it is truly empirical evidence. For researchers out there, look up the word empirical. Like when we say empirical, we're talking about a true environment where it wasn't us who did this in a artificial setting. The way we got the data is we gamified it. We created a hackathon. We called it the Visual AI Rockstar Hackathon. And we had 288 quality engineers using a variety of quality engineering open source software. Selenium, you probably heard of. Cypress, for sure, is currently really growing. WebDriver IO. We had these quality engineers compete to use their existing open source framework to solve for very common front-end testing and test automation use cases, and then repeat the whole process, infusing these open source frameworks with visual AI. And at the end of the day, 288 of these engineers spent on average 11 hours. That's a 1.5 years of quality engineering data. And it was empirically driven, right? It wasn't a subjective, it wasn't conversational. We were recording the time it took to author the tests, the time it took to run the tests, how effective or efficacious they were at managing quality, the stability of the test frameworks at the end of it. So it is, I haven't seen a study like this at this scale that I can think of, certainly not in the space we're in, which is DevOps and test automation. So that was where, the impetus for this and where we got the data from. And what we've done is finally analyzed all this information and released it in a very thoughtful, very transparent way.
You did touch upon some, but if I just ask you, can you just give us a summary of some of the key findings, what we learned through this report?
Yeah, so there were 5 or 6 key dimensions of data that we looked at. One was, how long does it take you to author or create your test suite, right? Very important to the ability for these developers and quality engineers to build coverage of the application, right? And we are talking about the front end aspects of the application here, functional and visual aspects of the front end application. So how quickly you can spin up and build a test suite and provide coverage is one of the key areas that we looked at. And what we found is that on average, using a typical kind of code-based framework like Cypress or Selenium or WebDriver IO, it was over 7 hours to actually build this set of suites that were part of the application. With Visual AI, it took an hour, right, for the same amount of effort. So that was one key dimension, is time to author new tests. A second very important dimension is how much code it takes. So the more tests, the ironic thing about quality engineering today is like you're actually writing a lot of test code in order to inspect your application, and you have to maintain that test code. And that's what's causing a lot of pain, a ton of pain in this community, where they're so focused on trying to use code-based frameworks and they have to maintain them, and they break. You're talking about, think about the locators, the assertions you're having to write with Selenium or some of these frameworks. All of those are subject to breakage every time the application updates, or even from an external source updates. If you can reduce that amount of test code and still have the same amount of coverage or more coverage, you're going to test faster, right? And you're going to spend time testing and not building your test suites and maintaining your test suites. So that was the second critical dimension, is how much code it took to provide the coverage. And we were able to eliminate, in comparing these two, about I think it was over 50% of the code. But you got to keep in mind, we eliminated 50% of the code, and it took an hour to write it versus 7 hours. So when you really think about coding efficiency, you saw close to a 6x improvement in overall code efficiency, which is really about how quickly can I write the code and how much coverage can I provide for every line I write. So that was a second really important aspect. It's very similar to the way feature developers think about it. They're looking for code efficiency at this time, right? And this is what quality engineers need to do the same way for their testing. Third dimension was stability. So whenever you have to assert things using a typical Selenium framework, those locators and labels will break. They throw a lot of false positives. So you're investigating things that aren't actually broken when a human being looks at it. So the fewer locators and labels and code-based assertions you have in your framework, the easier it is to maintain, which means you can provide more coverage. You can actually manage quality. You can release faster. That was another impact we saw, that the stability based on the number of locators and labels, Visual AI reduced that by orders of magnitude as a 4x improvement in the stability of the framework, right? So those three findings together are really the most compelling, and they lead to the fourth most important aspect, which is how effective were these frameworks at catching bugs and managing quality and catching these bugs pre-production, right? Early stage. And there was a 45% improvement using Visual AI, along with the speed and the ability to improve quality while still releasing faster. That's the important thing here, right? En route to true CI/CD, or even just improving your agile process, QA still is the bottleneck, especially the front end. And if we can unblock that and improve quality simultaneously, that's huge. That's huge for these tests, for the quality engineering effort. And so those were all of the major implications of this. And the fifth and final comment I'll make here is how easy it was to learn. I mean, this was gamified. We created a hackathon. We awarded prizes. So we really encouraged people to do their best to try to win and do as best they could. In the process of doing that, they got 1 hour of training using Visual AI. And they were able to achieve these results, well beyond what they were able to achieve with their existing approach in isolation after 10, 15, 20 years of having these technologies in market, right? I mean, Selenium automated browsers back in the late 90s. So a lot of conversation there. I hope people were able to follow that and listen in, and it was interesting for you. But this is really meaty stuff, and it's really, really good data, and research transparently delivered to the market, and I think in a way that's pretty unique.
All those key finding and learnings, they are like very valuable. But how do these, these engineers and developers or developers, they apply these learnings into the practice? And do you as Applitool also help them with their tools?
So we have a lot of support in that area. So first of all, we've got an open source learning community called Test Automation University. Think of it as an open source learning community where you're able to come in, and there's about 40 or 50 courses from instructors, the best people in the field of quality engineering. It's led by a woman named Angie Jones, who's really, really, really famous in the field. You can look at her profile. That's one open source resource where we upskill and educate, and we're seeing 1,000, 2,000 quality engineers signing up per week at this time because they see the opportunity to upskill and learn and frankly distract themselves while they've got time. Mixed into that learning is our technology, because we know we don't live in isolation. And so we want to actually train people to leverage visual AI, not in a rip and replace format, but how do you take what you've already invested in and take what you already know and make yourself better? So TAU, Test Automation University, vital place to go. And we've got some dedicated courses that show you how our technology, Applitools Visual AI, layers in. We have a free account. Once you're trained, you can sign up and use it for free to teach yourself. We also have a variety of online support. And then we have a very strong team that is able to work with larger companies and larger teams and literally train you, including administering the hackathon to your team in a private manner. Like we've packaged up this hackathon and done it, in a virtual setting for 10, 20, 30, 40, 50, 100 people as a way to bring the team together and have them learn something new. So we're really innovative and supportive of the community in that way, depending on, how big or how small a company you are. That's how we'll help you.
Awesome. Thank you, James, for taking time out of your busy schedule. I'm sure we are all stuck at home, so we do want some break from what we are doing. So thanks. I look forward to seeing you at some physical event whenever that happens. But for now, thank you, and stay safe and healthy.
Yeah, thank you. And if people want the report, just make sure they go to applitools.com. They can just download it, and it's a really, really comprehensive. And I really appreciate you taking the time to talk to us and learn about it. And we're proud of what the community contributed. It's really, this came from engineers directly, and so we're proud of it, and we hope people enjoy reading it. Thanks for your time.